Okay.
Sir,
Okay.
sir,
Yeah.
some practice questions here.
Sorry.
In this class, any practice question?
Yeah. So see, this is the first of all, this is the revision session. Okay. First, I will revise the concepts of week 3 and week 4. Okay. After that, we'll take the doubts from your sides. Okay.
Okay.
Okay. Yeah.
Okay.
Okay. So in week 3, is my voice clear to all of you?
Yes.
Yes, sir.
Okay. Great. Great. So in week 3, see, since till week 2, we had discussed about categorical variable, right? Charts of categorical variable. What are the measure of central range? I mean, a median, mode for the categorical variable and all right. Now we'll move to the something more regarding uh, numerical variable, right? So basically, for any kind of variable or data, we have two kind of things, right? First one is categorical, right?
Getting
And another is numerical. Okay.
your man.
So within a numerical, we have two kind of things. First one is discrete.
Sir, sorry to disturb.
Yes.
Now on YouTube, the class is not streamed.
Sorry.
On YouTube, the class is not streamed.
Okay. Let me check.
No, sir, it's live.
It's live.
Yes.
Okay. Okay. So can you check it's live?
Yes, sir, it's live. I got a
Okay.
notification.
Okay. So in discrete, basically, okay, how will you identify? I think we have discussed a lot about discrete and continuous in week 1 itself. Discrete is something when counting is there, right? And continuous something when measurement is there, correct?
Right.
This is something we have done already. Now, in week 2, we had done that, pie chart, bar chart, that are the visual representation for your categorical data. What about continuous kind of data, right? Numerical data, basically. So there is one something called for continuous data histogram, right? Histogram is basically is the no is a very appropriate representation, graphical summary. It gives a graphical summary for my continuous data. Okay. So are you familiar with this histogram, right?
Yes, sir.
Yes,
It's
sir.
like X, Y axis in the data between X.
For a continuous data. So basically, you can take any continuous data, right? Let's say you are taking the marks and all. So similarly, okay, you can make the beans, right? Like let's say in the bin of 0 to 10, there are some students. Let's say 20 students are there, right? In the bin of let's say 11 to 20, there are some 31 students, right? In a bin of 21 to 30 marks, there are some 40 students, something like that. You can make the bins, right? Yes or no? Let's say
Yes,
there
sir.
are some
Yes, sir.
80 student of a school or of a class. So similarly, you can make the histogram on bins on x-axis and number of student on a y-axis. Correct? So similarly, you can make a bins like so 0 to 10. Suppose 20. Okay, this is 0. Suppose 20 is here. Okay, so it will be like this. So then 10 to 12, 20. Yeah, I mean 11 to 20. It's a 31. So let's say 31 is here. Okay, so your histogram will be like this. Similarly, it will be basically you can say it's a continuous bars, right? Can I say or not?
Yes,
Correct?
sir.
Yes, sir.
It's a continuous bars. So this is something I can make the histogram. So basically in histogram there are some terminology. Let me just quickly go through it. So we'll move to the next topic because this is important. But okay. So there are something lower class limit. Okay. So okay, in histogram we are representing the class interval like this. Okay. So what is the lower class limit here? This will treat as lower class limit. Correct or not?
Right, sir.
And this will treat as upper class limit.
Upper class.
Okay. Now there is another concept called class width. What is that class width? How will you identify or how will you calculate the class width? So class width is nothing but
Upper
the
limit.
No,
Yes,
basically,
the
okay. Basically,
difference
suppose
between upper limit and lower limit.
no, no, it's not about upper limit and
Difference
lower limit.
between
This
the
is
upper limit
Next
and
lower limit of the
previous
next.
I
right
think it's the
limit.
average.
correct.
I think
See,
it's
see,
average.
it's not about upper limit and lower limit. Basically, difference between lower limit of this class and lower limit of the next class. So that is noted as the denoted as the class width. Okay. So the class width is nothing but C minus A.
Okay.
Okay. So okay. And what about class mark? These are just a terminology. Class mark is nothing but
Average.
average of the A plus B, right?
Lower and
A
upper.
plus B.
Right. That is something. It's just some technology and sorry, some terminology and all. Okay? So now let's move to the that is something called stem and leaf plot. Okay.
Yes, sir.
So if you see in stem and leaf plot, so this is something. It's a represent. See in stem and leaf plot, each observation is separated into two parts. First part called stem and second part called the leaf. Okay, let me clarify you. Basically, suppose one kind of stem and leaf plot. So suppose I want to represent the 75. Okay, so I can make a stem and I can make a leaf. So it will be in stem first and leaf 5. Okay, so there will be key provided for each every kind of stem and leaf plot. Key provided means there will be how we are going to interpret. Suppose I have written 7 oblique 5 means 75. Okay. And make a note in stem and leaf plot, observations are in ascending order already. Correct?
Yes, sir.
Right? So, okay. Suppose I'm saying, okay, what does this mean if I'm writing like this? That means
75, 76.
75 and 76. Okay. Let me write down something. Let's say I'm saying 8, 0, 1, 3, then 9, 2. Okay. What are the observations do you have?
80, 81, 83.
No, 75, 76, 80, 81, 83, and 92.
92.
So these all are observations from your stem and leaf plot. Correct or not?
Yes.
Yes,
Okay.
sir.
Let me draw again another stem and leaf plot. Okay. You will tell me what does this mean. This is suppose this is stem and this is the leaf. Okay. So sorry, just a minute. Let's suppose I have written 6, 0. Now tell me what are the observations is there?
60,
60,
61,
61,
70,
72,
2,
73,
73,
73,
74,
74,
92,
92, 95.
95.
90.
Sir, I think there
What?
is 8 and there is
No,
no
no.
leaf for that. What about that?
So
Is it
correct.
80 or it will be
No,
counted
no,
as 80?
no. If it will be 80 only, then if I will write 0 here. Okay.
Yeah.
If I'm not writing anything here, that means okay.
Literally stamp.
Suppose there is no observations from here. Okay.
Okay.
Or
Okay.
here. Okay.
There are no leaf, then how it will be interpreted?
Nothing. That is
So it will
missing.
be interpreted
Okay.
as 80
Basically,
or
What if we have something on the leaf side and not present on the stem side? Then
no,
also
no,
it
no. See,
will
see,
be
key. See, first of all, how you have to interpret your stem and leaf plot. Key will be provided. Okay. Key will be provided. Suppose I'm writing 8 something not that means there is nothing. Suppose key will be provided means suppose I have written 6, 0 means 60. Okay. It will be like this. Suppose you want to interpret three digit number. So key will be like this. 6, 0, 1 means 601. Okay. So key will be provided. So don't interpret except the key. Okay. If there is nothing, that means there is no observation for this stem and leaf. That's all. You can't say it's a 8. 8 means it should be 0, comma 8, right? Got it? So
Yes.
Yeah.
you don't generalize anything. Key will be provided how you have to interpret your stem and leaf plot. Got it?
Yes,
Yes.
sir.
understood.
Okay. So
But
okay.
if there is a single digit value, then
So pardon me, I have a question here. So
Yes.
you said like we can go for 3 digit as well. 6,
Hmm.
then bar, then 0, 1. Can we take it further, like 6 digit, 7 digit also can be done with
Yes,
this
yes,
way?
yes, yes. You can do. There is not a problem. But you have to provide key. Suppose you are giving me stem and leaf plot, so you have to provide key, like how I have to interpret my observations from the stem and leaf plot. Okay. If you will not provide key, then I can simply take this one 60 comma 61. Right. I can simply take, because you haven't not say anything, right? But you should provide
Understood, sir.
key how I have to take the observation, right?
Understood, sir. If the key
Sir,
what
what
has
if
been provided to us,
Yes.
uh,
Key will be
the
provided.
same, yeah,
Key will be
understood, sir.
provided.
If the graph is, for example, some of the part is not following, then we
Hmm.
can just leave it out and
Correct,
not take
correct,
it.
correct, correct.
Understood, understood.
Sir,
Sir,
I have
what
a
if
question.
we
Can
want
I
to
ask?
present 8 and we write 0 on the stem size and 8 on the leaf side, then will it be read as
Yeah,
8?
yes,
Sir, I have a
because
question. Can I ask?
because key is something I'm saying 6 oblique 0 means I'm going to interpret as 60, right? If you are going to write 0 obligate, that means 0 obligate means you are going to consider as 0, right?
Okay, sir.
Okay, got it? Yeah. So, but make sure observations this should
Sir,
be in ascending order. Okay.
sir, if the X is present in the data set, then how to calculate X?
X is present in data set.
Yes, sir.
Only X.
Yes, sir,
No,
only
there
X.
should be some another information also provided, right? Like median is this, mean is this. Only then you can compute the unknown value.
Sir, why this is not written in a simple
No,
format?
sir.
Why is
No,
this a
sir.
Hmm?
In the percentile questions, between the data sets, there is a X present also. Then we question
Percentile is
asks
there,
to,
right?
yes, sir.
Okay. So you can't say in
If
general.
and
Where
the
is that
question,
question?
I did not remember where I see the question,
Okay. So basically,
but
I need to check that question.
Sir,
Uh,
allow
I
me.
think in graded assignment
Yeah,
it
yeah,
is.
it was in graded assignment. Allow me a moment. I'll just check. I wrote an email to support team as well. Allow me a moment. I'll
week
just
three
find it
grade
out.
assignment.
Yes, sir.
Yes, sir.
anyone have to please, I have doubt
Allow
in
me.
that.
Allow me a moment. I'll just find it out.
Let me check where in this question. This one.
So it was graded assignment week 3, question number 3. The mean and sample standard deviation of data set consisting 10 observation is 15 and
That's the see. That's not related from this one, right?
okay, okay.
Okay, stem and diplo. I will come to that question. Okay, don't worry. I told you. Let me first of all cover the concept. Let me revise the concept. After that, we will discuss the questions. Okay. See,
Okay.
it will be in sequence, right? It will be in standard manner. Like we have discussed all the concepts, then we can discuss the questions. Otherwise, it will be like in between we are discussing something, then something. So there will not be sequence as well. Okay. So make sure. Let me finish the concepts. Let me revise the concept. After that, we'll take the doubts from your side. Okay. Is that okay for everyone?
Yes, sir.
Yes, yes,
Okay,
sir.
great,
Right.
great.
Yes,
So next thing is about measures of central tendency. Okay.
Yes.
So first of all, tell me what's the need of measure of central tendency? Why we are interested to know the measure of central tendency? So first of all, there are some. What are the measures of central tendency we have done in week 3? Mean,
Median mode.
Mode, median,
median, mode.
mode.
Okay. First of all, why we are interested to know the measure of central tendency?
to know how the data is varying.
Sir, to
To
know
know
the
how the data is
center of
varying.
data set.
Is that correct?
Sir, to know center of a
To
data set.
interpret the data set.
Basically,
indicate the speed of data set.
no, not spread. First of all, you are not listening the question carefully. I'm asking about central tendency, and I did not ask about the measure of variation. First of all, okay, let me clarify. So, measure of central tendency. Okay, so basically, mean, median, mode give me a central value. Okay, these are the measure of central. This will give you a single value. So, mean, and all is it gives me a central value. So, what's the need of central value? Suppose, okay, so please keep mute. There are some background noises. Okay, if you have any doubt, raise your hand and we can discuss. So, what's the need of central value and why I'm interested? Suppose I want to know average marks of a school, right? or simply I said is, average marks of students in school A is, let's say, 80. So this 80 gives me a central idea about the students, performance of the students, right? Rather than observing marks of every students, I got a central idea in a single number for that school A, right? So
Yes.
in such kind of scenario, let's say you are interested to know the average annual placement, I mean, package of the placement, let's say in IIT Kanpur. Okay, then you need only one number, right? Rather than seeing the seat of every student's annual package of every student, right? So it's good to take when you are interested in you represent your data set in a single number. So that single number I'm interested to represent as a central value. Okay, so mean, median, and mode. So I think you are familiar how to find mean, median, and mode. So basically, mean is nothing but, so suppose I have data set x1, x2
Average
up
of the
to
data set.
xn. Okay, so mean something I can calculate is nothing but sum of all the observation divided by number of observation. Okay, if there is something frequency is given to you, like for x observation x1, there is frequency f1. For observation x2, frequency is f2. For observation xn, frequency is fn. So how you can compute the mean? So mean is nothing but summation of fi into xi divided by summation of fi, right? So basically you have to do fi into xi and f1 x1, f2 x2 up to fn xn, basically, right? So this is something mean. And median is what? So median is nothing but, first of all, to compute the median, we have to arrange. Okay, so median is nothing but it gives the middle value. Basically, this is the value which divides the data into two equal parts. Okay,
And the data should be ordinal.
and to compute the median, we have to, first step, we have to arrange the data set in ascending order, right? This is the first step. Second step, to compute the median of a numerical data, first of all, you have to see what are the number of observations. Suppose you have number of, see, this n represents the number of observations. So you have to see whether this n is odd or even. It can be 5, n can be 6 observation, or if n is odd, right? Then median is something I can compute as n plus 1 by 2th observation of the data set will be the median. If n is even, then median is something I can compute as average of the middle observation in the ordered list. What is the middle observation? Basically, I have to compute the mean of n by 2th observation
N by 2 plus 1
and
observation.
n by 2 plus 1th observation. Okay, so this is something we are doing in case of median. So what is the mod? I will take the example, don't worry. Mod is nothing but the observation which occur more frequently, right?
Frequently.
Right, this is something mod. Okay, let me take an example. First of all, suppose I have a data set, let's say 1, 2, 3, 4, and 5. Okay, for example, suppose. Now, tell me, okay, suppose these are the,
Sir,
yes,
say you missed the box plot.
I will come to that point, don't worry. Okay, see me, box plot, how we, okay, box plot, what are the things box plot represents?
Okay.
Tell
Five
me,
numbers.
5 numbers only, right? I did not come to that point, right? Okay, so let me, I will come to that point, don't worry, I will cover
Okay,
the
sir.
each and every concept, okay?
Sorry.
Okay, suppose these are the annual package in lakhs, okay, in lakhs of any university of some for some 5 students, right? Then you might be interested to know, right, what is the annual average package, right? Average package of the students in that university, right? Something like that. Okay, forget about that. So basically, I took that example so that you can get idea to, suppose you want to represent your data set in a single number. So what can be that single number? It can be central value, right? Now, so tell me what is the mean of this data set? 1 plus 2 plus 3 plus 4 plus 5 divided by 5, which is 3,
Three.
right? What is the median?
Sir, three.
3, right?
Three.
Because it's
Three,
in
sir.
n is odd, so n is odd, so n is 5 here. So 5 plus 1 by 2th observation, right? Basically. So that means third observation. Third observation is 3.
Three.
Now, yes. So, okay, suppose there are something like that. Okay, I think I told to everyone, please mute yourself. There are some background noises, okay, which is not a good thing. Okay. Now I will come to the mod in next uh, concept. Okay, first of all, tell me, suppose instead of 5, I took 1, 2, 3, 4. Instead of 5, suppose I have 500. Okay.
Yes, sir.
Now tell me, what will be the mean now? What will be mean of this? It will be 1 plus 2 plus 3 plus 4 plus
It's
500 divided
501.
by 5.
Sir,
So it will be 510, right?
102.
Yes.
102. Okay. Tell me, what about median of this data set?
Three.
It won't change.
3.
It's not so, right? So can you tell me, can I simply say mean is sensitive or mean is affected by extreme
Less.
values, right?
Yes.
Yes.
Correct. So I can simply say
Yes.
mean is affected by extreme values, right? See, who is this Mox? Keep mute yourself. Otherwise, I will mute to everyone. You can't unmute yourself within the during the session. That's something I don't. Okay. So it's a request to everyone, mute yourself. If you doubt, you can unmute. That's not a problem. But after that, you can mute yourself. Okay. So it's a request. So mean is something affected by the extreme values. Correct? Can I say?
Yes, sir.
Right? Now,
Yes,
what
sir.
about median? So median is, I'm not saying it's not affected, it's the least affected, right? Because
Yes, sir, it's least
I mean,
affected.
suppose data is something like that, median is affected. So median is basically you can say it's least affected or somewhat is not affected by, right? Okay, correct. As compared to mean, right?
Yes, sir.
You
Extreme
got the
values in
idea?
this case is the end values, right?
Yeah, extreme value is 500.
But
It is
but in some cases, the extreme value can be in the middle also, right? In this case,
yes,
then
yes,
also the
yes.
mean
Yeah,
can
yeah.
be
Okay.
okay. Yeah.
So basically, mean is more affected by the extreme value as compared to median. Okay. So basically, see, like suppose you are going to in practical real life data, right? And there are some extreme values and all, right? So you will prefer median rather than mean. Okay. Because median will see, if you in your data set extreme value is present there, that means your central value will get changed significantly, right? So it's
Yeah.
good to use the median in that case. Okay. Now, okay, tell me. Okay, so suppose, okay, this is something. Suppose I took the data set like 1, 2, 2, 3, 4, 5. Okay. Now, let's say it's 5 and 6. Okay. Okay, tell me what is the mean? So it will be 5 plus 3, 3 plus 4, 7, 12, 18 divided by 18 divided by 7, right?
Yes, sir.
Okay. So what is the, okay, let me take it rather than 18. Let me make it as, okay, let's make it some divisible content. 9. Okay. If I will write this as a 9, that means it will be 21, right? Okay. So mean is 3, correct? Now,
Yes, sir.
tell me, okay. Now tell me, suppose I want to add a constant. Okay. Okay. What is the median?
Also three, sir.
Right. This is the middle observation, right? Because it's n plus
Yeah.
1 n plus 1 by 2th observation. That means 7 plus 2 plus 7 plus 1 divided by 2. That means 4th observation, right? So fourth observation is this 3. What is the mod?
2.
2.
Okay,
Sir,
suppose I want to.
Sir, I have a doubt here.
Yes.
Sir, I think median is calculated for ordinal data only.
So it's in order already, right?
Sir,
Yes,
Sir,
sir.
mod is 2 and 4 also.
No,
4
not
is
4. This
written
is
2
5.
times. 5, sir.
Okay, so this is in order already, right? Okay.
Okay.
Yeah. This is already in ascending order. You can see 1, then 2, then 2, then 3, then 4, then 5, then 9, right? Suppose
No,
I want
sir,
to add a
sir,
constant. Yes.
One doubt, sir. We use median for like just rank 1, rank 2, rank 3, like this order, sir. Or for this order, we can
No,
calculate.
so you can
It happen in categorical data. It is a
so
numerical
that's
data.
in happen in categorical data. Median is applied only for ordinal data, right? Ordinal means the something which you can order. The numbers, these are the numbers. These numbers you can order, right?
Yes, sir.
Correct. 1 comes before 2, then 2, then 3, then 4, then 5, then 9, right?
Okay.
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 Yes.
Mean should be 26.7. Yes, sir. It will be 26%.
Yes, sir.
Okay. Once again, I think we have done the wrong. Okay, 3, 2, 5, 3, 8, 4, 12, 5, 17. It should be
26.
okay. So I want to make some numbers which are divisible. Okay, so let me make is it's coming out to 26, right?
Yes, sir.
Okay,
Yes.
9, 5,
Let's make
14,
a 4.
4, 18, 3,
10
21.
Sir, we can take 5 instead of 9. It will be 29.
One second.
Sir,
14, okay, one second. 18, 3, 21, 23,
write
25,
one more
26,
2.
right? So rather than 26, if I will increase, let's make
7,
it as
4,
11.
28.
Now it's 11, then it's 28,
Yes, sir.
right? 16, 20,
Yes, yes.
yeah, 28, right? So now mean is 4,
Yes, sir.
right? Now, okay, so far so good now. Now,
Yes, sir.
suppose I want to add a constant, let's say 2 to all these observations. Then what will be the my new data set? New data set will be 2, 4, 4, 5, 6, 7, and 30. Correct?
Yeah.
Correct or not? So
Yes,
what
sir.
will be the mean now? Mean will be 2 plus 4 plus 4 plus 5 plus 6 plus 7 plus 13 divided by 7, which is 6. Now tell me, this 6 is nothing but 4
41 by
plus 2,
7.
Yes, sir.
right?
Yes,
So
sir.
can I say this is the new mean? This one is the new mean. New mean means mean of the new data set. Correct?
Yes, sir.
And what about this?
Yes,
This
sir.
is the old mean.
Old mean. New mean is
So
equal to
new
old
mean
mean
is
plus
nothing but
constant.
old mean plus that constant value.
Yes, sir.
Yes, sir.
Correct?
Yes, sir.
Okay, let me write it here in general. So here C constant value. This C is nothing but 2 here, right? So see why this is important. Suppose in a class there are some 80 students, right? And class teacher gave marks to 80 students, and after that after evaluation of the copies he realized there is one incorrect question, then he wants to give 2 marks to each of the students, right? And see, then after that you want to compute the average of the new data set, right? Then rather than again adding all marks of all the students, then dividing, so we can use direct properties, this one, right? New mean, suppose we know the old mean plus that constant, correct or not?
Yes,
Yes,
sir.
sir.
Right.
Correct.
What about median of this data set? New median.
Median.
Median is
Same, sir.
5, right?
Oh, sorry, sir. Median plus constant.
So median is 5 here, right? So that
Yes.
means
Yes, sir.
3 plus 2, and 3 was the old median. So can I say new median is equal to old median plus that constant? Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. What about new mod? New mod is here 4,
Yes,
Yes,
sir.
sir.
4.
Yes, sir.
4.
4, which is nothing but 2 plus 2,
2
can I
plus
say?
2.
So new mod is this is old mod, right? Mod of
Yes,
old
sir.
data set plus that constant,
Constant. Yes, sir.
correct? Got the so far so good?
Yes, sir.
Yes,
sir.
sir.
Now Suppose I want to multiply it by a constant 2. Then, so this is the data set 1, 2, 2, 3, 4, 5, 11. So old data set I had 1, 2, 2, 3, 4,
4,
5, 11. Okay,
3,
3, 4, 5, 11.
5,
Suppose I
11.
want to multiply it by a constant c. Okay,
So let's suppose 2.
yeah, multiplied by a constant. Let's say I'm taking as a 2. Then what will be my new data?
So
New
2,
data
4,
will be
4,
2,
Old into
4,
4,
2,
4,
2,
6,
4,
8,
8,
10, 22. Correct? Now, tell me
Yes.
what will the new mean? New means
New mean is
new mean means mean of
8.
this new data set. It will be 2 plus 4 plus 6 plus 8 plus 10 plus 22 divided by 7. So which is nothing but
8.
8, right? So this is 8 something I can write down 4 into 2, right?
Yes, sir.
yes, sir.
Correct?
Yes, sir.
So what is this 4? This 4 is nothing but old mean of the old data set, correct? And
Yes.
this 2 is nothing but that constant value, correct?
Yes.
Okay, sir.
Can I
Yes,
say
yes, sir.
new mean is old mean into say? Suppose you know the mean of old data set and then you multiply it by 2 to all the observations. Then rather than calculating mean again for all the observations, it's good to just multiply by that constant into old mean, correct?
Yes.
Correct. The same
So
thing
your
I can.
voice is breaking.
Is it for everyone?
It's clear.
Yes, sir.
No,
Now
sir.
okay.
Sir,
Okay.
No,
no,
sir.
I
sir,
think
your
you
voice
might
is
have
good.
some network problem. Please check. Okay. So what is the median for this data set? So median for
Video
this
is
data set,
also like this.
6.
6 is the median, right?
Yes, sir.
Yes, sir.
Correct. So this is the 6. So can I write down 3 into 2, right?
Yes, sir.
Yes,
So
sir.
new median is this 3 is the median of old data set
Yes, sir.
into 2 is nothing but that constant value, correct? Right. What is the mod of new data set? Mod
Old
is
mod into
4.
4.
4.
Mod is 4, right?
4 into 2.
4 into 2.
4.
Yes, sir.
Not 4 into
No,
2.
sir.
2
Mod is
into
4.
2.
2
It's
into 2.
2 into 2. So 1, 2 is 1, 2 is the old mod. Okay, mod of the old data set, and this 2 is nothing but that constant value, right?
Yes, sir.
Is
Yes,
it
sir.
clear for everyone?
Yes, sir.
Yes, sir.
Okay. Now, suppose now I think you got the concepts of this central tendency and all, right, everyone?
Yes, sir.
Yes, sir.
Okay. Adding a constant, multiplying a constant, something like that.
Yeah.
Okay.
Yes, sir.
Now,
Yes.
Yes, sir.
come to the concept of measures of central sorry, not central measures of dispersion. Okay. So as name suggests dispersion, that means we are interested to know what is the variability in my data set, right? What is the spreadness in my data set, right?
Yes, sir.
Correct. What is the spread?
Yes, sir.
Okay, so anyone can tell me what is the need of variance? Variance means what is the need of suppose you are interested to know the like dispersion or spreadness in your data set or variability in your data set. Why?
So, sir, so that we can differentiate between two data sets,
Yes,
Okay.
sir. Because
even
in
if they have
center.
same mean and median.
Yes,
Correct,
sir.
correct, correct. So I took the example of that college one, right? Suppose in a university A, packages of some 5 students like this, okay? And in a university B, packages are like this, okay? What is the average value here? 3. And what will the average value here? 3, right? Now, suppose I told you, suppose I represent PPT in front of you and told you the annual average package in both university are same, right? So is this true? In reality, is that correct one?
No, sir.
No, sir.
I mean, annual
Annual
average
average.
package is 3, but
Yes.
I can't say both are the same, right?
Yes.
Yeah.
Because
Yes, sir.
if you see data are varying, correct?
Yes.
So in that type of scenario, variance, standard deviation, that's helpful for us, right? So there are something measures of dispersion. So first one is range. Okay, the range is very straightforward.
Yes.
So range is nothing but
Maximum minus
so
minimum.
it's a range is nothing but you can simply say range is nothing but maximum minus
Minimum.
minimum of your data set. Let's say you have 1, 2, 3, 4, and 5. So what will the range of this data set? It will
5
be
minus 1 is equal to
4,
4.
right?
Four.
Basically 5 minus 1, you can say simply range is 4 lakh, right? What about this data set? You will simply say 0.
0.
Correct. So you can you observe the spreadability there, right? Spreadness there,
Yes.
correct? So that is something range. So can I say, okay, instead of suppose 5, let's take a general data, you have 500. Then what will be the range? Range will be now 499.
490.
Yes, sir.
So can I say range is very sensitive to outlier?
Yes,
Correct?
sir.
Yes, sir.
Yes, sir.
Because this is sensitive to extreme values, right? Because see, range consists only maximum minus minimum, right? And extreme values are will be your at the both end, right? Normally,
Yes,
correct?
sir.
And range takes only two observations of data set, right? Okay, so that's why we are
Excuse
jumping
me, sir.
into the variance. Yeah. Let me finish first. Yeah, go ahead.
Sir, can you please explain the concept of outlier? Does that mean we are adding a new value or we are changing the existing value?
No. Actually, I took that example randomly. I just want to explain the concept. What is the meaning of outlier? So outlier is nothing but which is suppose you plot a scatter plot, and outlier is nothing but which is very far from the normal observations. Basically, okay, that is something considered as the outlier of your data set. Okay, maybe very extreme values, which is not a normal observations. Okay, so that is something
Okay.
called outliers. Okay, so I'm just changing the observation to give you idea. I'm not saying you have to change 5 as 500. Okay, so
Yes, sir.
now let's come to the
Sir,
variance.
outlier come in between the values or it come outside the values?
See,
Sir, like
outliers.
that, sir, no, sir. I mean to say that 1, 2, 3, 4, 5, 4, and 500. The
Mhm.
outlier each come between 1, 200, 3, 4,
It
and
can be,
5.
but once you plot the scatter plot or something like that, scatter
Yes.
plot or box plot, that 500 automatically will visible outside that plot, actually. So
Okay.
that, see, outlier is that kind of observation which is far from your normal. Okay.
Values. Yes, sir.
So next one is the variance. Basically, so in contrast of range, why we are considering variance? Because variance takes into account all the observations, right? Okay. It
Yes,
also
sir.
tells you the spreadness, but it tells you because it takes into account all the observations. Okay.
Yes,
Now,
sir.
so basically, what are the, see, there are two kind of formulas for the variance. First one is called population variance. Okay. And another is called sample variance. Okay, so population variance, nothing but notation for it. This is sigma square. It's 1 by n summation of I equal to 1 to n xi minus x bar square. Basically, it tells you the spread or deviation of each observation from its mean. Okay. So basically, in population variance, we are considering all the observations, right? All the number of observation, and there is something called the sample variance. What is this? Is denoted notation for this s square, which is nothing but 1 upon n minus 1 summation I is equal to 1 to n xi minus x bar square. So in sample variance, the only difference is about n minus 1, this denominator case. Why is that so? When you will come to in stats 2, right, you will know why we are considering n minus 1. So there is one concept called unbiasedness and all, and we are losing 1 degree of freedom and all. So that's why it's n minus 1. That's not our case. So far, for this foundational course, you can keep in mind for sample variance, we are using n minus 1 in denominator. And for population variance, we are using n in the denominator. Okay, so there is one formula you can keep in your mind. Okay, so this is, suppose this is the case, this is the formula. So can I say n times of sigma square is same as summation of I is equal to 1 to n xi minus x bar square?
Yes, sir.
Yes, sir.
Correct?
for the sample variance, can I say n minus 1 s square equal to summation of I to n xi minus x bar whole square?
Yes, sir.
Yes, sir.
Now can you see right hand side are equal,
Yes, sir.
right?
Yes, sir.
So can I equate left hand side,
Yes, sir.
right? So can I can just to, tell me, can I do something like that? Sigma square is okay. So this is very you can say simply important equation. You can keep in your mind. So basically, this is very important. Suppose I have given you a small n and population variance. Then I ask about without giving you observation. I ask about tell me the sample variance. Can you tell me now?
Yes, sir.
Yes,
Right?
sir.
You have to just put the value of n and you have to just put the value of sigma square. You will get the s square, right?
Yes,
Or
sir.
Yes.
see, there are three unknowns n, sigma square, and s square, right? Any of the three unknowns, suppose any two are given to you, n and sigma square, then I ask s square, you can tell me values, right?
Yes,
Or
sir.
suppose n and sigma square is given to you, sorry, s square, you can tell me the sigma square.
Yes.
Suppose
Yes,
sigma
sir.
square, s square is given to you, you can tell me the n value of n,
Yes,
right?
sir.
So this is something
Yes,
you
sir.
can keep in your mind. You can treat as a important formula. Okay. You can take a screenshot or something like that. Okay. So
So
this
I
is
think this is the question I was asking. I got confused and I could not fill in the graded assignment. Thank you for clarifying.
we'll discuss, don't worry. Okay. Okay.
Sir,
So yes,
so can you explain once more?
this one.
Yes.
Okay. So I have sigma square as 1 by n summation I is equal to 1 to n xi minus x bar square, right?
Okay.
So if you multiply n to left hand side, so can I get n sigma square equal to this equation, this quantity?
Yes.
Same if I will multiply n minus 1 to left hand side in case of sample variance, I will get this value.
Yes.
So I can you see this right hand side are equal? Then can I equate left hand side?
Yes.
Okay, this is something you can get. Okay,
Sir,
Okay.
what the mean of covariance and
I
correlation?
will come to that point. That is in week 4. I told to everyone in initial of the at the beginning of the session. I will
Okay, sir.
go okay sequence. Okay, okay. So it's okay so far. Now tell me, in case of mean, median, mode, we saw what if I will multiply it by a constant, what if I will add a constant. So can you tell me if I want to add a constant C, then what will be effect on my variance? First of all, tell me. Okay, so I will take the example only from the population variance and you can simply do for the sample variance also. Okay, suppose I want to, okay, suppose I have observations x1, x2 up to xn, right? And I want to add a constant c, then what will be my new observation? X1 plus c, x2 plus c, right?
Yes, sir.
Xn plus c, right? Let's treat this as y1, y2 up to yn. Okay. Now
Yes.
tell me what will be the my new variance? Sigma square new. It will be 1 upon n, summation I is equal to 1 to n, yi minus y bar square. This will be my new variance, right?
Yes, sir. Yes,
Now
sir.
let's put the values here. So 1 upon n, summation I is equal to 1 to n. What is the yi here? Or xi plus c
Yes, sir.
minus. What will the y bar?
X
Y
bar
bar
plus C.
y bar represents their mean of the new data set, right? So x
N
bar
plus
plus
C.
c,
Yes.
correct?
Yes, sir. Yes.
Can I put here x bar plus c, then whole square, right?
Yes. Yes,
So
sir.
1
Yes, sir.
upon n, summation I to n, xi plus c minus x bar minus c whole square.
Yes, sir.
C will get cancelled out here.
Yes, sir.
What you got here? 1 upon n, summation I to n, xi minus x bar
X
square,
bar.
which what is it? This is nothing but sigma square of
Old
whole
value.
data set.
Yes, sir.
So
Old
can I
value.
say there will not be
No
any
change.
effect by adding or subtracting a constant in case of variance, right?
Yes.
Yes, sir.
Correct?
Yes, sir.
Got it? Now,
Yes,
suppose
sir.
I want to multiply it by a constant, then what? So 1 upon n. So yi minus y bar whole
It's
square.
multiply by constant square.
Okay, correct. So your yi will be what? Xi times c,
Yes, sir.
and y bar will be x bar times c. Correct?
C. Yes, sir.
So c I can take outside, so it will be
Common.
c square into 1 by n. summation I2n xi minus x bar whole square.
Yes, sir.
Correct. So what is
Yes,
this?
sir.
This is old variance,
Sigma square.
right? So if I want to multiply it by a constant to each observation, then my new variance or variance of new data set will be square
The
of that
square of the
constant
constant
multiplication by
multiplied
old
by
variance.
variable.
Correct? This is clear
Yes,
to
sir.
everyone?
Yes.
Now,
Yes, sir.
come to that concept called standard deviation. Okay, first of all, what is the standard deviation? Why we are what's the need of that standard deviation? Basically, standard deviation is
Square.
nothing but square root of variance. Okay,
Then
that is something we know. But why we are doing? Why we are doing square root of variance?
It makes it as a square. So the standard deviation, it brings back the unit. Actually.
Correct. Basically, that will help us to compare in original unit. What we mean by original unit? Suppose your x represents the age of person, or let's say weight of person. Okay, for example. Okay, then variance you will get. Let's say something x in kilogram square, right?
yes, sir.
If I will do standard deviation, I will get square root of x kilogram. So now it's easier for us to compare my data set because your initial data set in kilogram, in a unit of kilogram. So then your unit will be the same. So it's easier to compare. Okay. So standard deviation nothing but square root of the variance. Then what will the population variance? It will be square root of 1 upon n summation of these things, right?
Yes, sir.
And what about sample variance? 1 upon n
1 upon
minus
n
1.
minus 1 summation
1
of
upon n
y
minus
minus
summation
x
of
bar
x
comes
Okay.
to
What about suppose I want to add a constant c then?
No change.
No changes.
Because
No
you
change.
know sigma square new is nothing but sigma square old, right? So
Yes,
standard
sir.
deviation means what? This is nothing but square root of both sides,
Yes, sir.
yes, sir.
correct? So that means s new is the same as s of old, and
Old.
not s is sigma. Okay, correct?
Yes,
Now
sir.
suppose I want to multiply by a constant c, then what we got? Sigma square new as nothing but c square
C
into sigma
square
square
sigma
old, right?
square old
So what will, if you take square root, then what you will get? Sigma new is equal to
equal to
c
C
into
sigma.
sigma old, right? The same you can apply for the sample variance as well, right? This is clear for everyone?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Any doubt?
Yes, very
No,
good.
sir.
No, sir.
No, sir.
Yeah, clear. Okay, so next concept called the percentile. Okay. So what is meaning of the percentile actually? So any one of you have given the JEE exam or CAT exam?
Yes, sir. I give J means
Okay.
Yes, sir.
So you got your marks how
80%.
Percentile.
80
Percentile.
percentile, right?
80.
So what is the meaning of 80 percentile?
80% of people are less than me,
Correct. And 20% people are
are upper.
above you. Okay. So that is
Yes, sir.
meaning of percentile. So percentile means okay, suppose I'm saying 25 percentile. That means
Then
25%.
75%.
5%
Okay,
equal.
suppose this is 25 percentile. That means 25% of the data set will be less than equal to it, or
Yes, sir.
75% data set
Upper
will be
than.
above it.
Upper.
Okay.
Yes.
Yes, sir.
Suppose you got 90 percentile in CAT exam or in JEE exam. That means 90% of the students, I mean marks of 90% of the students are below you. Suppose this
Below.
is you. Okay. Remaining 10 marks of 10% of the students are
Above.
above
Above you.
Above.
percentile. Okay. So there is a one method
Uh,
to compute the
Sir, I have
percentile.
a doubt on this.
Yes.
What is the difference between percentage and percentile? Could you
Okay. So
just
basically,
briefly?
see, that is something we are trying to explain. Yeah? So suppose I'm saying you got 80% mark. Okay.
Okay.
Okay. So
Yes, sir.
80. Okay. Suppose you got 80%. 80% means you are. Suppose there are 100 students. That means you are 80th one, right?
Okay.
Something like that. Okay. So what is meaning of percentile? Suppose I'm saying there are some. Okay. Okay. There are 100 students.
Okay.
Okay. Then suppose I'm saying you got okay, they will get some marks,
Mm-hmm.
right? So that
Yes, sir.
means okay, they will get some marks in the exam.
Yes, sir.
In an exam, so they will, I mean, they will score some marks and all. Suppose you got, I'm saying you got 85 percentile. Okay,
Okay.
what does this mean? That means 85% of the students, right? 80 marks of 85, okay, that marks can be anything, it can be 2 3 something like that. Marks of 85% of the students will be below you. Okay,
Okay.
that means
Okay.
you are not, you did not got 85% marks, it means 85. So your marks can be anything, suppose you got 60 marks, okay,
Okay.
but 85% of the students got less than 60 marks.
Okay.
Okay, and remaining 50% of the students will get the more than 60, which are above you.
Okay.
Okay, so that is something meaning of the percentile. So in sim, there are some background noise. Harshvardhan. Okay, now understood the concept basically. Suppose I'm saying simply, let's say 30 percentile. Okay, okay, I'm saying 30 percentile. So 30 percentile means 30%. Suppose this is you. So 30% of the students, marks of students will be below you, and remaining 70% of the marks of the students will be above you. Okay, so that is something uh, called as a percentile. We can interpret the percentile. Okay, rough idea is okay for the percentile.
Yes, sir.
Okay, let's see the procedure how we can compute the percentile. So basically, to compute the percentile, what is the method? First of all, you have to, since it's a percentile something, right? So we have to see the ordered way, right? Basically, we have to arrange the data in ascending order, right? Or increasing order.
Yes, sir.
This is the first step. What is the second step? So you have to identify what is your N and P. Okay. Third is
And
something like, if you to compute the value of N into P. So this value NP can be integer. I mean, maybe integer, may not be integer, right? Correct. So if value of NP is not an integer, okay, not any integer, I will take the example, don't wait, not an integer value, then we have to take the smallest integer greater than NP. Okay, so smallest integer greater than this value NP, and we have to take the data value in that position, and take the data value in that position. In that position means just smallest integer greater than NP. Suppose you got value of NP as 1.2. So 1.2. So what is the greater integer after that? 1.2. 2. So you have to take the second observation from that data set. Okay. Now, if NP is an integer, then what we have to do? Then we have to take the then I have to take the average of the values in the position NP and NP plus 1,
One.
right? Right? So far, so good. Let me take one example that will give you clear idea. Suppose I'm saying I have data set something 12, 15, 11, 13, 14. Okay, for example. So what is the first step?
Arrange the data
Arrange
in
Arrange the data
ascending
in
order.
ascending order, right?
Yeah,
So
11,
it will
12,
be 11, 12,
13,
13,
14, 15,
14,
14, 15.
correct?
15,
What is the N here? 5.
11,
5.
5,
Yes,
5.
Suppose,
5, 5, 5.
suppose I
number
ask,
of observation.
yeah, N is the number of this, which is 5. Suppose I ask, tell me the 30th percentile. So P, I have to take 0.30.
Fuck you, I started using that.
Alag kya? I think I should take some. Okay, so P will be 0.30. if I'm interested to compute the 30th percentile of this data set? Yes or no?
Yes, sir.
Yes,
Right?
sir.
Yes,
So
sir. Correct.
after that, we have to compute NP. So what is the NP? 5 into 0.3. That means
1.5.
1.5. So this
1.5.
is
Sir,
in
sir,
this.
how you compute P, sir?
I just took randomly. I'm saying I'm interested to compute the 30th percentile of this data set. Okay. So that means P will be your 0.30. See, 30th percent is 30 divided by 100, right?
Okay,
Yes,
sir.
sir.
Okay. So
Okay.
this is not an integer. So we have to take the next smallest. That means second
2.
2. So that means what is the second observation in my data set?
12. 12.
12, right? In arranged data set, not in previous. So that means 30th percentile of my data set will be what?
12.
12. Yes
Yes,
or
sir.
no? Right?
Yes, sir.
Yes,
Suppose,
sir.
okay, let me take some another, suppose, let
Sir,
me
I have a
increase.
doubt here.
Yes?
Sir, I have a doubt.
Yeah.
Let's say we go ahead with 36th percentile and we end up with 1.8, and again the closest one is the second observation. So the 12th number will be again, that will be 36th percentile.
Yes, yes, yes. See,
Okay,
this is
so
a very, very, very small data set actually we have. Okay? Yeah, actually. So in that, okay, so okay, yeah, go ahead.
So the way in percentage it works, we can get exact decimal points also. It does not work the same way in percentile. It goes approximately nearby kind of thing, right?
Yeah, yeah. That's why we are taking the next smallest integer, right? Basically, okay.
Okay.
Let me tell you one thing. Okay, just give me a minute. Let me connect my laptop. The charging. Yes. So basically, what does this mean? Suppose I'm saying suppose this is the smallest observation of your data set. This is the maximum observation of your data set, right? Or let's say 100th value, something like that. Okay. Suppose I'm saying this is the 25th percentile. Okay. So that means if suppose this is smallest, this is 100th observation, right? I mean smallest, this suppose this is the first observation, right? This is 25th observation. Okay. So that means what? 23 observations will be in between these two, right? Can I say?
Yes, sir. Yes, sir.
Yes, sir.
Okay, got it. So that is something. So this is very small data set. That's why we are getting the same value actually. Okay. So
Okay, when we have more like larger data set,
then we'll
then we
get
can.
the exact value. You see, okay, if you are getting the 36th percentile as the same 12, right? Or 40th, you will get something mean of these two, right? 12 and 30.
Yeah.
Okay. So basically, see what does this mean? Suppose you okay, that observation can be anything. 12. So it can be anything between 12, it can be 12, 12.1, 12.2, or also all the observation can be 12, 12, 12, 12, or 13, 13, 13 between these two, right? Something like that. This is very smallest data. That's why we are getting the same one. Okay. So let's try to understand the key concept here. Okay. So suppose n is 5 and p is equal to 0.40. I mean 0.40 means suppose I'm interested to compute the 40% of my data set, right? Then what will be value of np here?
2.
2.
2.
Now it's in integer, right? If it is integer, then we have to take the average of the second observation
And third observation.
plus third observation. Yes or
By
no?
2.
By
Yes, sir.
2.
Yes, sir.
What is the second observation? 12. What is the
12.
third observation? It is
13.
13.
15
So
by
12 plus 13
25.
divided by 2. So that means 12 point.
5.
Is it clear?
Yes, sir.
Yes,
Sir.
Rough idea is okay for everyone?
yes.
No.
Yes,
Yes, sir.
sir.
So,
Sir, can you explain second one again?
okay. Let me clarify it. So n is 5, right?
Yes,
P is
yes.
0.4, right?
Yes,
So
sir.
value of n into p is 2.
2.
So
Yes.
this value can be integer, cannot be integer, right?
Yes, sir.
So here this is not an integer value. Oh, sorry, this is an integer value.
Integer value.
If it's integer value, then what we have to take? We have to take the average of NP and NP plus 1th observation.
1.
So NP means 2,
2.
NP plus 1th means third. So we have to
Third.
take the average of second and third observation. So what is second observation? Second observation is
12.
12. What is the third observation?
13.
13, right? So what
Yes.
what is the average of these two? 12 point.
12.5.
12.5.
Got it?
Yes, sir.
Okay, yeah. So next one is called quartiles. Yes.
Sir, if this NP will be 3, then also we have to take the third and fourth observation,
Third
right?
and fourth observation. Yeah. If it's integer, that's why I told you NP. Okay. Let me take that one also. Then after I will move to the next. Okay. So suppose I'm interested to calculate the 60th percentile. So NP will be 5 into 0.6.
Yes, sir.
That means 3. This
Yeah.
is in integer value. That means we have to take the average of third observation plus fourth observation, right? So third is 13, fourth is 14. So 13 plus 14 divided by 2. So 27 by 2. So 13.5. Clear?
Yes, sir. Clear.
Okay, great. So next one is the quartiles concept. So okay, what do you mean by quartile? Quarter?
Yes, sir. So 1/4.
One-fourth part
One
of
fourth of the data set, right? Basically, quartiles is nothing but it divides your data set into 4 equal parts.
four
Suppose this
part.
is your data set. So one equal part, second. I mean, this is somewhat it's not equally I have done here. Let me redo something. Okay, just this one. Now it seems approximately equal, right? Just treat all the 4 parts are equal. Okay, I'm just giving you a rough idea. Okay, so this part, 4 parts is this part, this part, this part, and this part are equal. So it divides my data set into 4 equal parts. That's why it's called quartiles, means quarters actually. So now we have to there are some things. So this is called the this one is called the first
Q1.
quartile, which I'm representing as the Q1. This is called the second quartile, which I'm represents as Q2. Called the third quartile. Now you have seen the in the percentile case. Okay, these all are 25% part, right?
Yes, sir.
Yes or no?
Yes, sir.
Now tell me what is the Q1? Q1 will be nothing but
25%. 25% of.
25th percentile. Can I say?
Yes, sir.
Because 25% of the observations are below it and remaining 75% observations are above it, right?
Above it. Yes, sir.
Correct? Yes or no?
Yes, sir.
Yes, sir.
Tell me about Q2. Q2, can I say 50th percentile?
58%. Yes, sir.
Right? What does this mean? 50% of the observations are
Are
below
below
it, and you can
50%
say
are above.
remaining 50 are above it, right?
Above it. Yes, sir.
Clear?
Yes, sir.
Now, what about Q3?
75%.
75 percentile.
So 75th percent, that means if you see 75% of the observation, that means if you see this 25, this 25, this 25. So 75% of the observations are below it,
Below
and
it
remaining
and
25% are above it. Right?
above it. Yes, sir.
So far, so good. So basically, this
Yes.
is called the first quartile. Okay. And this is called the second quartile, which is
Or
nothing but see,
medium.
if you see Q2 is what? It divides the my data in 2 equal parts, right? 50
Yes,
below
sir.
it, 50% above it, right?
Above it.
So this is called also median of my data set. Okay. And this is called the third quartile of your data set. Now, can you compute this all things? Okay, let me take the previous example, 11, 12, 13, 14. Okay, let's compute all these things. So 11, 12, 13, 14, my data set is already, I have taken in arranged order. Okay, tell me, what about Q1? Q1 means I need 25th percentile, right? So that means N is 5, right? P will be how much?
0.25.
0.25. So what is the value of NP here?
1.25.
So 5 into 0.25, that means 1.25.
25.
That means this is in decimal. So that
Yes.
means second observation.
Second
Right?
observation.
Second observation is what? 12, right?
12.
So my Q1 is nothing but
12.
what about Q3? So N is 5, P is 0.75.
2.7.
So value of NP is 5 into 0.75. That means 3.75.
3.6.
Yes.
That means see
Fourth
thing is
observation.
in decimal. So that means fourth observation. Correct?
Yes.
Yes.
Fourth observation is what? 14. Right? So my
Yeah.
Q3 of my this data set is 14. Is it clear?
Yes.
Yes, sir.
Okay, so see if any question is there in related to this quartile and all? Can you compute it?
Yes, sir.
Yes,
Okay.
sir.
Now,
Yes,
next one is called IQR. IQR means full form of this IQR is
interquartile
interquartile range.
range.
Okay. So what is
Yes.
interquartile range? This is
Q3
nothing
minus
but
Q1.
Q3 minus Q1. Suppose
Q1.
I ask what is the interquartile range of the above data set, that means 14 minus 12, which is
2.
2. Right? That is the very clear idea. Okay.
Yep.
Next one is, suppose I have given a data set to you and I ask what is the outliers, or suppose I ask, is there any outliers present in your data set or not? Okay. Suppose that is the question. So you can find whether outliers is there or not. So outlier is something you can find out such that you can simply calculate if outlier is an observation if which is less than Q1
Q1 minus
minus
1.5
1.5
IQR.
times of IQR, and you have to test whether is there any observation which is greater than that Q3 plus 1.5 times of IQR, that will consider as the outlier. Got it?
So
Yes.
please
So
take an
basically,
example for
okay,
this.
yeah, I will come to that. So suppose I took that example 11, 12, 13, 14, and 15, right? Suppose this is data set. Okay. Now, okay, what is the Q1? Q1 was 12, right?
Yes, yes, sir.
Yes, sir.
Minus 1.5 times IQR was
2.
2, right? So what
Yes.
will be value of this? 1.5 times 2, that means 3,
3.
right?
Yes, sir.
So that means 12 minus 3,
9.
9. Okay, can you check, is there any observation in your
No.
data set which is less than 9?
No.
No,
No, sir.
No.
right? Tell me Q3 is 14 plus 1.5 times 2, which is 17. Is there any observation which is greater than 17
No.
No.
in your?
No, sir.
That means there is no
No
outlier
outlier.
in this data set. Okay,
Yes.
Okay.
got it? So this is
Sir,
something.
could you come again with formula, sir?
Sorry.
This the higher outlier and lower outlier. Could you come?
Hmm?
Yeah, just wanted to see that. This 1.5 plus 1.5 into IQR for higher one and minus 1 Q1 plus.
Yes. Basically, you have to identify, is there any observation in your data set which is less than this quantity, then that will be considered as the outlier in your data set. Now, if is there any data set which is greater than this quantity, you can consider as an outlier of data set. Okay.
Sir, is there any reason to have 1.5, or I mean, is there
Actually,
any?
there is the reason, but if you are going that, there will be a little bit depth something. So for now, you can just keep in mind. Okay, we can discuss on it more, but let's finish the concept. Okay,
Thank
I'm not denying it, but
Sir,
there is yes.
sir, can you please explain this one more time? Actually, I just
Okay,
missed it.
this outlier thing.
Yes, sir.
Okay, so suppose I asked a question or someone asked you a question, identify whether is there any outlier in your data set or not. So basically, you can simply check. There is one method to check whether outliers are present in your data set or not. So you have to check, is there any observation which is less than this quantity, Q1 minus 1.5 times of IQR, that will be considered as a outlier. And if there is any observation in data set which is greater than this quantity, Q3 plus 1.5 times of IQR, that observation you can consider as a outlier. Okay.
Okay, sir.
Yeah,
Okay.
got it, sir.
So there is one, someone asked box plot. I don't know his name. So basically, box plot.
Yes, sir. It's me.
Okay, great. So box plot represents like this. Okay. So basically, this represents the minimum value of your data set, and this represents the maximum value of your data set, and this represents the Q1, and this represents the Q3, and in between Q2. Not, it will not see Q2, it will not be exactly between Q1 and Q3. It will depend, it will vary as per the data set, but it will be in between Q1 and Q3. So basically, this is called the 5-number summary also. Okay. So what is the 5-number summary of any data set?
So minimum Q1, Q2,
Yeah,
Q3,
5-number
and maximum.
summary of a data set. means minimum value of your data set, what is the Q1, what is the Q2, what is the Q3, what is the maximum value. So box plot is very good representation basically for five numbers of okay, suppose you plot a box plot, right? And you got any observation like this or any observation here, this, that means this is the outlier of your data set. Okay,
Yes, sir.
got it? Clear?
Yes,
Sir,
sir.
can you please explain it again?
This one again.
Yes, sir.
Yes, yes.
Okay, so this is the representation of your box plot. This is something called box plot. So this box plot is nothing but it's a representation for five number summary. So what is the five number summary of your data set? So it's nothing but whatever data set you have. Suppose you have given the minimum value of your data set, first quartile of your data set, second quartile of your data set, third quartile of data set, and maximum value of your data set. So that is called the five number summary of your data set. Okay. Now visual representation is something, this is called box plot. So the box plot looks like something like this. So this will represent the basically minimum value of your data set, and this box, lower part of this box represents the Q1, and Q2 will be in between Q3, Q1 and
Sir,
Q3.
sir,
It will.
can you plot this box plot above example, sir, which you
You can
given?
simply plot, right? What is the minimum value? What is the maximum value, right? You can plot simply, right? Minimum is 11, maximum is 15, Q1 is 12, Q3 is 14, right? Median is what? Median will be your 13, right? You can simply
13.
plot, right? So it will be your minimum value, it will be 11. So just you have to put the value, that's all, right? That is not that big tedious stuff, okay?
Sir,
Yes,
So
is this
basically
the
yes, sir.
same?
Q2 will be in between Q1 and Q3. It can be anywhere, but it will depend on the data set. And this is the maximum value, which is a 15 here, right? Since now, if you will plot the box plot for this particular data set, which I have taken earlier, you will not get any outlier. Okay. So what is outlier? If there is any outlier in your data set, then it will represent like this. Okay. Above the maximum value and below the maximum value. If there is something like that, that means these are outliers in your data set. Okay.
Okay. Yes, I got it.
Okay.
Sir, is this the same graph of like the candlestick that shows on trading chart?
Which one?
Is this similar to the candlestick shows on trading charts?
Yes, yes.
Yeah, might be. Actually, I need to check. I'm not
Yes,
sure
sir.
about that trading one. Okay.
This
Yes, sir.
points, the number
Minimum
of
and
points,
Q1
sir,
can be same.
Sorry.
The
this
minimum
number of
and Q1
points,
value can be same.
Minimum of?
The minimum value and the Q1 value can be same also.
Yeah, it depends on the data set, right?
If in the given
Minimum.
data, if it is, and then it can be, yeah.
Yeah, it depends. See, I'm not
Yeah, you can.
saying it will something. Okay, so first of all, it will be below that one. Okay. Like, okay, it can be same when something like you are getting 11, 11, 11. Let's say you have 25 times 11, right? Then you will get Q1 and something like the same, something like that. Okay.
Yeah, yeah.
Basically, this is the box plot is a good representation for five numbers someday. Whatever the minimum data set, sorry, not minimum data set, minimum value of your data set, Q1, Q2, Q3, and maximum, right? Okay. So no, now so far
sir,
every
two
Sir,
yeah,
I have a doubt here,
outliers,
sir.
the number
yes,
of dots, it represents the number of outliers.
it represents the,
So,
what is your outliers in your data set actually.
yeah, if I have two outliers
Yes,
above that
yes,
max range,
yes.
two
It will
dots
be
should be
fin-
there.
Yeah, yeah. It will not be less.
Sir,
Suppose there
here
is
the
only.
outlier.
Hmm? Yeah, yeah. Go ahead.
Sir, here the outliers, they should
Huh?
be the minimum and maximum value, no, sir, because they are included in the data set. So they should also be considered in the data set. So the maximum value will be the maximum outlier, no, sir.
No,
No,
no, it's
no,
not
no.
like that. Okay, maximum and minimum. Basically, this. Okay, sometimes. Okay. So basically, see,
Sir, so outliers are not considered inside the data set.
I think
outliers.
maximum is 100%.
Yes, basically, maximum is something. See, maximum is what? It's not like you have given the. Okay, basically, I told you, right? Minimum value less than, I mean, outliers are less than minimum value of Q1 minus
1.5
Yes,
times IQ, right? So basically, this is something Q1 minus 1.5 times of IQR, okay? And this is something Q3 plus 1.5 times of IQR, okay? So if any observer which is greater than this will be outliers. Any observer which is less than this will be outlier, okay? That's the case.
So it will not be considered in maximum and minimum
No,
case.
it's not like suppose in your data set you 5,000 is there and 5,000 extreme you are considered as maximum, right? Don't be like this, okay?
So
Okay.
let's say
Okay,
if,
sir.
if, if let's say if there is a number, before 11 and after 15, that in that case it will be considered as outlier.
Yes,
I'm
yeah,
yeah.
for this
So
particular
in
data
this
set.
in this data set you didn't have those numbers, so that's why I
Yeah,
guess
correct. In this data, we
people are
don't have
confused.
any outliers. Okay, we have seen we don't have any observation which is less than 9, and we don't have any observation which is more than 70. Right? Okay.
Yeah.
Clear? Okay. So far.
Sir, I have another doubt,
Yes.
sir. Related.
Yeah.
Sir, can we say always the Q1 and in a workflow Q1 and Q3 the middle value is the median?
Can you speak a little bit loud because I'm not able to hear you properly.
Yes, sir. Can we say always Q1 and Q3?
Huh?
The middle value like Q2 is always a median.
Always a
Median.
can anyone can hear you? I'm not able to hear properly.
Median.
Voice is very low.
Medium.
sir, I think it's in median.
No, what is he
I
asking?
think
Anybody?
he's saying Q1 and Q3. The middle value always be median.
Yeah, Q2 is always treated as median, right? We have just discussed. Q2 is median. Q3 is the first quartile. Q1 is the first quartile. Q3 is the 75th quartile, and Q2 is the median. Okay.
So is there any equality sign in between to find outliers?
Equality sign.
Yes, sir.
What do you mean
In
by
this question,
equality sign?
12 minus 3 is equal to 9. We can see is the 9 less than data or 9 also
No, it's a less than.
less than.
Yes.
Okay, sir.
So I think
Sir,
yes.
I am
You
audible
say,
properly.
you said any number greater than 17 will be an outlier, but at the max, you have written 15 there.
Who?
Sir, at the max of bar, what
Huh?
the graph, you wrote
Huh?
15, but
I wrote.
any number greater than 17 will be outlier.
This is the maximum value of your data set actually.
Sir, you wrote there Q3 plus 1.5 times the quartile.
Okay. Okay. So I was trying to explain that Q3. Okay. So
My
okay,
question
I
is
got.
that
Okay, I got. Okay. Yeah. Basically, this is the something 70. Okay. Yeah, correct. Thanks, Paul. Yeah. Okay. So basically, after that, it will be considered as the outliers. So basic
Yeah.
key observation is if there is any observation which is less than this, it will be outlier, and greater than this, it will be outlier. Okay. Greater than this quantity. Okay.
Sir, am I audible properly now?
Yes. Please go ahead.
So my question is in box plot. Suppose Q2 is not given.
Okay.
Uh,
No.
and
If
Q3
first
and
of all,
Q1 is given that
okay.
we
First of all, let me clarify. If you are plotting the box plot, Q2 should be there because
should
box
be
plot
there.
represents the 5 number summary.
Okay, suppose that Q3 value is not there.
I told right, Q3 should be there.
Okay.
Box plot is for this 5 number summary. Minimum, Q1, Q2, Q3, and maximum.
So my question now is like this: can we find the Q3 and Q1 average to Q2? The average of Q3 and Q1.
No. First of all, let me clarify. If you are plotting the box plot represents the 5 number summary of your data set. Okay. That means
Yes,
you have minimum value, you have Q1, you have Q2, you have Q3, you have the maximum value. Okay. Only then you can plot. And Q1, Q2, Q3, it's simply you can find out as the same thing we have done earlier, right? Percentile concept. Okay. Okay.
Sir,
So
minimum would be 9 here, right?
minimum.
Yeah, that's something. Actually, I was trying to explain that concept. Accordingly, we can plot the box plot. Okay, I wrote by mistake that way. Okay, don't worry that. Okay, so basically, I was trying to explain the concept. So this is something Q1 minus 1.5 times of I Q R. Okay, is that clear now?
Yes,
Just it's still nine.
Yes,
Yes,
sir. Move to the another part.
Okay. Okay, so let's move to the concept. I think week 3 we are done, right? Week 3 concepts, right?
yes, sir. Yes, sir.
Okay. So let's move to the week 4. It's already 7:30. No problem. We'll try to cover up how much we can cover. Let's see. Okay, so still week 3, week 2, in week 1 and all, we introduced with the data, categorical, numerical, and all. And in week 2, we saw the kind of what are the measure of central tendency we can implement on categorical data and visual representation of categorical data and all, right? And
Yes, sir.
in week 3, we saw something more about numerical data, right? What are the measure of central tendency, measure of dispersion and all on
Yes,
the
sir. Yes, sir.
numerical data, right? And visual representation, some quartile percent. Now, suppose I have two data or two kind of variables, then what, right? Then, and I'm interested to know whether those two variables, see, it might be an interesting question, whether those two variables are associated or not to each other, right? Suppose I
Yes,
have
sir.
given you anything, any data. Let's say I'm saying age and weight, right? Age of 10%, weight of 10%, and I ask you, tell me whether these are associated or not. That might be a question, right? So for that, we should be some graphical representation, right, to get a quick idea, correct? So that is the, see, age and weight are the numerical variables,
Yes, sir.
correct or not? What
Yes,
about categorical variable? How will you know whether two categorical variables are associated or not? Right? First of all, tell me what is the meaning of association?
When
What do you
just
mean by the
what, sir?
association?
One
One is
variable
dependent on
explain the
other.
other variable.
Correct? One is dependent on another. But basically, can I simply say if I have information about one variable, I can tell that provides the information about another variable?
Yes, sir.
Yes, sir.
Or
Yes, sir.
or if I'm going to make a change in one variable, that will give me a change in another variable if both are associated.
Yes, sir. Yes.
Yes, no,
Yes,
that
sir.
idea is clear now.
Yes, sir.
So let's see association between two categorical variables. Okay, so first thing we will see association between two categorical variables. Okay, so now I'm going to take the example the ma'am which took in the uh, lecture video. Just tell me. So basically, that is one categorical variable was ownership of a phone, right?
Yes, sir.
Yes, sir.
Okay,
Another is gender.
gender, right? Do let me know if I'm taking it some gender, right? So can you say, okay, ownership that have two category, a yes or no?
Yes, sir.
Gender has two category, female
And male.
and male, right?
Yes,
So,
sir.
okay, first of all, these two are the categorical variable.
Yes,
Yes,
sir. Yes, sir.
ownership is the categorical gender. Now I'm interested to know whether these two are associated with each other or not, right? Now, so for this, something we can make called a contingency table. Okay. So what is this contingency table actually? So this represents the basically count for each thing. Means count for, suppose this is the ownership. Okay. Suppose I have written here ownership, and suppose I have written here yes. Okay. And no. Okay. Suppose this is the gender. Gender, let's say female and male. Okay. Anyone can tell me the values, please? That will be easier for us. Yes.
Yes.
Yes, sir.
34 and 42.
For us, 34 or
And
no 42?
no,
No.
sir. For
No,
10.
No,
10.
sir.
No 10.
10 and 34, sir.
No is 10, right?
Yes,
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 sir.
sir.
Okay.
And male age 42 years
42 and 14.
42
and
14.
14.
Okay. Okay. Clear. Right now. Okay. Tell me. That's okay. Okay. First of all, tell me. Okay. This will represent the row total,
Yes, sir.
Yes, sir.
and this will give me a
Column.
Total.
column. Okay. First of all, tell me. In week 2, you have done the relative frequency, right?
Yes, sir.
How
Yes,
you can
sir.
find the relative frequency?
Sir, we totally sum up the
Frequency upon total.
and upon total
Okay.
number of frequencies.
Frequency divided by
Upon total.
Number of
Total
frequencies.
observation.
total observation, right? Now,
Yes.
so if I want to calculate the row relative frequency, then this will be 44 and this will be 56
Yes.
and this will be 76, this will be
76,
24, total is 100, right? Now,
Yes.
Yes.
so if I want to compute the row relative frequency, be clear with what I'm talking about, row relative frequency. So I'm interested to compute relative frequency, but row relative frequency. That means this divide by this row total.
44.
Yes, sir.
Relative frequency is what? Frequency divided by total, right? I'm asking
Yes, sir.
row relative frequency. That means frequency divided by row total.
Total.
Correct or not?
Yes.
Yes. No. So let me draw another table for the same. Okay. So this is yes. This is no. This is the gender. This is the ownership of phone. Okay. And this is the female category. This is the male category. Okay. Okay. So 34 divided by 44. Okay. Let me convert into percentage also. So it will be
77.27%.
34 divided by 44 into 100. So it will be something 77.27%.
27%.
Right? For no, it will be 10 divided by 44, right?
40, yes,
So
44.
10 divided by 44 into 100, that means
22.5.
22.73. Okay, now. And what about male?
Sir, male is
42 upon 56.
56.
Okay, so that means basically we have to do 42 divided by 56,
56.
14 divided by 56. So 42 divided by 56 into 100 will get
75%.
75%. And 14 divided by 56.
Divided by 56.
25%.
So 25%. So this is the okay. What about last? So last will be 76% and 24%, right?
24%. Yes, sir.
76%, 20
And 24%.
Now, if you see what are the values we have, basically, let me write down in some another color. 77.27%, then 22.73%, first row, right? Then 75%, 25%, right? So there is one concept called, okay, so the same thing I can apply the, okay, before going to that, tell me. So there is one concept called if all the row relative frequencies are same, okay, approximately same or similar, then there is no association between that categorical variable. I will tell you why. Okay, can you see this row relative frequency is 7624 is about this one, right?
Yes, sir.
Or about this one also,
Yes, sir.
Yes, sir.
right? Both are, I mean, approximately close. Not, see, there is not any significant change, right?
Yes, sir.
Yes, sir.
Okay, now, so if all the row relative frequencies are same, okay,
So can you please tell us how much is approximate?
it's not that much. There is any standard rule. It should be approximately same. I will tell you one another diagnostic. I mean, how you can relate. Okay, let me clarify. Okay, if all the row relative frequency, okay, or similarly column relative frequency, okay. So, okay, as we have computed the row relative, you can compute the column relative or not. Means 34 divided by 76, right? 10 divided by 24.
24.
Similarly,
42
42 divided by 76, 14 divided by 24, right? I can do
Yes,
that.
sir.
44 divided by 100, 56 divided by 100. Then you have to compare all the column like this, right? Got it?
Yes, sir.
So if all the row relative frequencies or column relative frequencies are approximately same or similar, okay, then
No association.
two categorical variables are not associated. Right? If row relative frequency, okay, I'm writing in some short form, or column relative frequency are not same for all rows or columns, then two variables are associated. Okay. Now
Yes, sir.
I will clarify. Okay. So 100% stacked bar chart, everyone, right? We have done 100% stacked bar chart. So what it represents? So it represents basically the things. It's the same as bar chart, another bar chart. So we are doing in the segment. We are dividing the bar chart in the segment. What do you mean by segment? Suppose I have plot a bar for female category, right? Then male category. So we'll divide the, okay. So before, what is the stacked bar chart? So how many female are there who are saying S?
Female,
34, right?
34.
Yes, sir.
Okay. Suppose this is the 34 female and 14 saying no, right?
Yes, sir.
Yes.
Yes,
Suppose
sir.
this is
No,
the
sir.
14.
10,
So
10,
basically
10.
10, right? Suppose this is the
10.
10. Okay.
Yes.
Just give me a minute, please. Yeah. So basically basically see, bar chart is for count, right? And segment bar chart nothing but it's also for count, but we are if we see we are doing in segments. So this 10 represents the, let's say I'm representing with different color, okay, with green, right? And this 34 is for red, right? So it will split, basically it split the things, right? Are you getting my point?
Yes,
Correct?
sir.
Okay. Same for male. How many male are saying S?
42.
Sir, 42.
Right? And how many male are saying no?
14.
14.
14.
Something like that. Okay. So suppose these are saying S, right? This number of male and this number of male are saying no, right? So this is something called stacked bar chart. Now, what is the 100% stacked bar chart? Basically, 100% stacked bar chart are very useful to compare the same thing, right? Let me do the, suppose this is the 0%. Similarly, let's say 5%, 10%, or 1%, 2%, something. I mean, scales we can decide, right? 5, 10, let's say 15, 20, 25, or for our simplicity, let's take it. Let me just give me a minute. So let's take it 10%, 20%, 30%, 40%, 50%, 60%, 70%. I mean, let's up to 100, right? I mean, it will be 80, 90, right? So just scaling we have to adjust, okay? It will be 80, 90, okay? So I'm just considering this up to 100%, okay? Is it okay? Are you getting the idea? Right?
Yes, sir.
So this
Yes,
is just considered as, so scaling should be same, 10, 20, 30, 40, something like that, okay? So I'm just erasing this thing so that if later you will not get any confusion. Suppose this is the 100%. Okay. Now tell me for female. Okay. So 100% means first bar will be like this till 100%. For male, second bar will be like this, right? What is the
Yes.
percentage of female who is owning the phone?
22.
77.27, right? Okay. So I'm representing with green color. Suppose 77.27 is somewhat here. Okay. Okay. This green represents the ownership of the phone, correct?
Yes, sir.
What is the male count? 70,
75%.
75%, right? So it will be somewhat here.
Yes, sir.
Okay. Now let me use another color. And remaining is for female who is not owning a phone.
22.73%.
Correct. That will cover the remaining area, right?
Yes, sir.
Now, what was the definition for association? You told me change in one variable should represent the change in significant change in another variable, right?
yes, sir.
Okay. Okay. Now tell me this is the gender one, right? And this is something telling the percentage ownership of on how many yes, how many no, right? Now, if I will do a change in one variable, let's say female to male, is there any significant change in the green to red or red to green?
No, sir.
Both are approximately same.
Yes.
Yes, sir.
If there is
Yes,
not
sir.
any change, that means I will say there is no association.
Yes, sir.
Now you will get the idea why we are saying if row relative frequencies are approximately same, then we'll see there is no association.
Yes,
Yes,
Clear?
sir.
Yes,
Yes,
sir.
sir.
This one is clear.
Yes,
Now,
sir.
for any data set, suppose you got the something like that. Okay. Okay. This is suppose 0%. This is the 100%, and this is the let's say female. Male. It can be anything. You can take, income, expenditure, something like that. I'm just going to give you idea of it. Okay. How will you identify? So suppose this is the bar. Okay, and this is the another bar. Okay, for male. Suppose for a data set you got something ownership of for female like this, for female like this. Okay, and for male you got the like this. Okay. Okay. Let me for female they are saying no for this, and for male they are saying no. You can take anything to agree for going a trip and something like that. Okay, agreement on going a trip, something like it. You can take any kind of now can you see tell me if I'm going to change in one variable, there is significant change in another one.
Yes, sir.
Yes.
Correct or not?
Yes.
yes,
So if all the row relative frequencies are not same, right? If there is significant difference, then I will say both are associated.
Yes, sir.
Got the idea?
Sir, we have to check the row related frequency and column related
Both?
frequency.
No, not both. Anyone. You can go with the anyone.
If anyone, if I check the column, it is not associated, then I don't need to
Correct.
check the row.
No. Only anyone. Either you can go with the row relative frequency or go with the column relative frequency. Okay.
Sir, if
Okay.
row relative is associated, like, does it mean the other one is also like same?
Same. Both will give you the same answer. See, anyway, what we are doing, just try to understand the concept. What you are doing, you are just going to find out the percentage in terms of first. You are finding in terms of row. Another is column, right?
Yes, sir.
Right. You are just changing the relative frequency. You are just changing the way of comparison. Both will give you
Sir,
the same answer. Okay.
in this continuous table, is there any possibility to have all the rows and columns different as well?
All the rows, yes. Then you will
All
get
rows and columns.
you will get the stacked bar chart, something like that, 100% stacked bar chart. Okay.
Sir, this bar chart is showing that these both variables are associated, right?
Yes, because if you are going to make a change in one variable, you can see the significant change in another one, right?
Yes, sir.
Okay. So just give me 2 minutes. I will have some water. I will be back. Okay. Hello.
Sir.
Yeah. Okay. Great. So
Sir,
now we have seen. Yes.
Sir, in this question,
Hmm.
this value are associated or not?
Which question?
In this example, ownership
So
of
in this, there is no association for that particular value because for this table, okay, we got the 100% stacked bar chart like this, okay. I took this as a random example. Suppose you are getting something like that. If all the row relative frequency are not same, then there will be association between those two,
And
okay.
sir, if you take column related frequency for this
Anyone,
examples,
anyone. You can
sir,
go with the either row related frequency or column related frequency. It doesn't matter. Both, anyone will be better. Okay. There is not any. I mean, like you have to compute both row related frequency and column frequency. No, you can go with anyone.
sir, can you please tell when I calculated this? I calculated the column related frequency for this. Can you please note down and then, sir, little bit explain about it, sir, for because I have some confusion in this, sir.
What is your confusion?
Sir, when we calculate column related frequency, then we got ownership of phone for female is 44.74%, and
Okay, okay. One second. Don't get confused. Okay, so you are saying 44 point.
74%.
Okay, so you got one column 44.74. Okay, for yes.
For yes, female.
Okay.
And no, sir, 41.67%.
Okay, no problem. Then for male?
For male, sir, yes, 55.26%.
55.26%, okay.
And no, 58.33%.
Okay.
And sir, last column total is 76%. And
76%?
Yes, sir, column total, sir. Either yes.
No, it's not 70. Okay, okay. Now, okay. I think you got confusion. What you have done, you have computed the your row related frequency. You have done 76 by 100, right?
Yes, and here 20.
That's not a case.
Okay.
See, what you have done, I think I got your mistake. See, you have done 34 by 76.
Yes, sir.
10 by 24.
Yes, sir.
42 divided by 76, 14 divided by 24, right?
24,
You are
yes,
doing in column. What you have done in the last 76 by 100? Is this column? No. You're dividing with the row total, right? You have to do 44 divided by 100, 56 divided by. You see what you are doing? 34, then
yes,
76. You are comparing the column relative frequency, right?
Yes, sir.
Okay. So it will be 44%, 56%, right?
Yes, sir.
44%, 56%, correct?
Yes, sir.
So now you have to compare by this, like this column. Okay.
Yes, sir.
Got it?
Yes, sir. Sir, here we got similar value.
Yeah, similar value. Okay. So
Sir,
there is
we
no
compare
association.
between, sir, 1 second, sir. We compare between female and male, and yes.
Each column, yes. So you can see there is one column. This is main column, right? Correct? And
sir, there is any criteria by which we can decide this is similar or not? Because
no,
we
similar is approximately same. I mean, see, it's so not, there is not any criteria to like, but the main thing is you have to, if there is significant difference means, suppose this is 44, okay? For example, 44%, this is, let's say you got as a 21%, okay? And this is something you got, let's say 19%, for example. I'm just taking some random value, okay? And here you got, let's say 78%. Now it's a significant difference, right?
Yes, sir.
Okay, so there should be some significant, or simply what you can draw. I told you, just draw this. Just compute the row relative frequency and draw is 100% stuck bar. You will get a very quick idea whether there is significant change or not.
Okay. Okay.
Okay. Oh.
Yes, sir.
Sir,
So
is there
far,
any possibility,
yeah.
sir, is there any possibility if a row relative frequency is same and a column relative frequency is different, or
No.
vice
No.
versa?
No. Actually, the same thing I told you. What we are doing, what we are comparing the relative frequencies in just a different way. First, see, at the end, what you are doing, you are just dividing by total female. This is something first criteria, right? Correct. And
Yeah.
another criteria, what you are doing, the female count who are saying S, right? So you are just doing in a different way. Okay, it should not be like you are getting row relative frequency similar and column relative frequency significant different, right? Okay. So we
Yeah,
are
got
doing just in, see, the way are different, but we are going to compare the same thing, right?
Okay, sir.
Sir, is this data set association between both the rows and column?
You tell me what we have discussed.
I think they are, yeah, this is association.
Association. No association. Approximately same are there, right? We plot the 100% stacked bar chart, right? You can see the both are approximately same, right?
Yeah.
Okay. Association means what? If I will do change in one variable, I'm going to get the change in another variable, right?
Okay.
Okay. So if you do change in one, let's say I'm going to female to male, is there significant change in yes to no or not? Something like that, bro. You can see approximately same are there, right?
Oh, okay. Okay.
Okay. But in the another graph, I took some random data. Suppose if you, I'm going to change, can you see the significant difference? Green and red, right?
Yes, sir.
So that means they are associated, right?
Yes, sir.
Clear? Okay. So next one is, see, so far we have seen association between.
Sir, I have doubt.
Yes.
Actually, please down the page.
Okay.
Uh, Slightly
Okay.
more. Uh,
This one.
yeah, yeah. Actually, if we wish to find association between them, then we will check also row total.
Yes, yes, yes.
Uh,
We have
Actually,
to basically we are interested to compare the row relative frequency, all row relative frequency
uh,
visible.
so the row total will be also compare or not?
Yeah, yeah. That's why I have circled this green one, right? So
Oh,
basically, if you see, okay,
these two will be considered.
this one, and this one. Okay. Basically, if you see in 100% stacked bar chart, what
Oh
we are
yeah, yeah,
saying,
got it.
okay, what we are saying, 76% are saying yes, right?
Mm-hmm.
Something like that, right? So if you see total 76% are saying yes, and within that, what are the percentage for female? Something 77, right? Something like that, right?
Yeah,
So
77.23, I
that's
think.
why we are comparing total one. Okay.
Mm-hmm.
Okay, so till now we have seen the association between two categorical variable. What about association between two numerical variable? Okay, just a minute. Yeah. So now we'll see association between two numerical variable. Okay. So there is one quick way to identify a relationship between two numerical variable. What is that? Anyone?
Covariance and correlations.
No, no, no. Quick way means I saw, suppose I given you two data. One is
Of,
year and one is weight. How will
uh,
you,
uh,
without any calculation?
I think we will plot a scatter plot.
Correct, correct, correct. So first and foremost thing, first of all, plot a scatter plot. Basically, when you will STD, I mean, that is not in our foundation level course. Basically, suppose you are going in, suppose you are a business consultant or business analyst, something like that, and you want to predict the house price. Okay, house price in a locality, something like that, right? So before that, you must know what is the relation between size of the house and price of the house, correct? That might be an interesting question, correct or not?
Yes,
So
yes.
basically, you will plot a scatter plot to see whether size is increasing, then price is decreasing or not, something like that. Whether size is increasing, price is increasing, correct or not? Right?
Yes, sir.
So that
Right.
might be a question. So scatter plot a very good thing to give a quick idea for the compare of two numerical variable. Let's say I have one variable. So one basically we are plotting on x-axis independent variable. Independent variable means suppose this is x and this is y. So independent variable on the y response dependence are there. Let me tell you what I mean by independent. Okay. Suppose I'm saying I have one variable called age and one is called weight. So which will be independent?
Age.
Age, right? Age will be independent, right? Weight can depend on age, right? Age is increasing, weight is also increasing, decreasing, something like that, correct?
Yes.
Yes,
Okay.
sir.
So on the x-axis, we are plotting the normally independent variable, and y is a response variable or a dependent variable. Okay. Suppose I have size of the house and price of the house. Okay. Then which one is the dependent and
Size
which
of
one?
the house.
Size. Okay. So on x-axis, it will be size. On y-axis, it will be price, right?
Price of
Right.
house.
Yes, sir.
Okay. Okay. So let me give you some rough idea. Okay. Suppose I have given a data set, some previous data, and I got the pattern between data set like this. So what does this mean? There is positive association Yeah,
Yes.
linear association, right?
Yes.
Positive association means x is increasing, y is also increasing.
Yes.
So
Correct.
what is linear association?
Linear means there is a linear trend, right? You are not going to get a plot like this, something curvature, right? Okay. So in our course, we are bounded to the linear association basically. Now suppose you plot the data set and you got the pattern like this. What about this? Negative,
Negative association.
Downward trend.
right? Downward
Negative
basically.
linear
Means
association.
if I'm saying x is increasing, then y is
But y is decreasing.
Decreasing.
that means negative association, right? What about this plot? Something like that. Is there any trend? No trend, right?
No
No,
trend.
no
No
trend.
That
There is
means there is, I can simply say, there is not any association between the x and y, correct?
no.
Yes.
Yes.
sir.
But this was a quick idea. What about I want the things in number? Okay. So for that, covariance comes into the picture. So covariance basically tells us the linear association between two
numerical.
Numerical variable.
numerical
Variable.
variables. Okay. Now, covariance basically tells us the linear association between two numerical variable and it has unit. Okay, I will tell you what. Okay, so basically, what is the formula for covariance? Let me just write down the formula. So as we have done population variance, population sample variance, so there is something called population covariance. So what is the formula for population covariance? Nothing but 1 upon n summation of I is equal to 1 to n xi minus
Minus
x
x bar
bar
X
and
bar.
yi
into
minus y
yi
bar.
minus
Y
y
bar.
bar. And for the sample covariance, okay, is nothing but 1 upon
1
n
upon n
minus 1
minus 1
1
summation
i
of
is equal to 1 to n
I1
xi minus
xi
x bar.
minus x bar into y
into
minus
y
y bar.
minus y bar.
Now tell me one thing. This is nothing but represent the covariance between x comma y, right?
Yes.
Suppose I asked what is about covariance between x comma x, then what you will get? 1 upon n summation I to n xi minus x bar,
Whole square.
then xi minus x bar, it will be 1 upon n summation of xi minus x bar square
Whole
whole
square.
square. What is
Yes,
this?
sir.
This is variance
Sample
of x,
variance.
Variance.
population variance, right?
Population.
So that means basically covariance is defined for the two variables. And if I want to find the covariance between the x and x, same variable, it will give me the variability of that data set, right? That's the another concept. Okay.
Sir,
Tell
can you
me
explain last step again, sir?
this one.
Yes,
So
sir.
if I will replace y with the x, I will get the xi minus x bar.
Yes, sir.
It will be 1 upon n xi minus x bar. What is this? That is variance of x, right? So basically, covariance, if you see, is defined for the two variables, two different variables. Okay,
Yes.
one is independent, one is dependent. We want to find the association between those two. If I will replace the same variable y with the x, I will get the variance. Okay.
Yes, sir. Yes, sir. Understand,
Okay.
sir. Got it.
So this is the covariance formula basically. Okay. So covariance has the unit, right? Because if you see, as I took age as x, then what will the unit? Unit will be year or month, something like that, right? I asked to everyone in initial. If you, once you ask your doubt, right? Please mute yourself because there is some background noise. Okay, you can unmute whenever you have doubt, but after that please mute yourself. Okay, so why
Will
we
there be any
wait, right? Yeah, please go ahead.
will there be any problems on x comma x, or is it just for our understanding?
No, it's just for understanding. I mean, so okay, it's a simple mathematics, right? Yes. I will
Yes, yes.
replace y with x. I'm going to get the variance, right?
Yeah, I was
I
just
just
interested to know
actually
the
I got this formula, then I thought let me explain this concept. Okay. So what will be the formula for I mean, unit for this covariance here?
So year kg.
Year into kilogram, right? Now you can compute the covariance, right? From your data set. I'm not going to compute, right? I see you have to do simply xi minus x bar, then y will
Hello,
be
sir.
y will be given to it, then y bar, and you have to do the multiplication of those two and then divide by n. If it's asking about population
Hello,
covariance,
sir.
yes.
So when will it our maths class is going on?
Okay, math class is started. Revision session.
Yes, sir.
Yes, sir. It was 8 p.m.
For 8 p.m. to 10
Okay,
p.m.
okay, okay, okay. So let me stop here. Okay, and Friday we have mock session, right? So first we will
Yes,
cover the
sir.
remaining concept, correlation and point by serial and all, and then we'll discuss the mock session. Okay, mock question. Okay.
Sir, I have a doubt in that best fit line, sir, after this correlation topic.
Okay, I'm not going to yesterday correlation because you guys have the math session. So Friday we have session right 8 to 10. Okay. So
Yes, sir.
first in that session, first we will revise the remaining concept. Okay, we are stopping here covariance, and then we will continue the discussion for the mock. Okay.
Yes,
Okay.
sir.
Okay.
Sir, please.
Sir, can I ask a doubt, sir?
Yeah, go ahead. So those who want to attend math session, they can go. And now I
Okay.
yeah.
Sir, practice assignment 4.1.
Practice assignment 4.1.
Question
Okay.
number 1.
Question might be different actually. First of all, let me clarify because
Okay, sir. It's second question, sir, in your assignment.
this one
Yes, sir.
355
Sir, yes, yes, yes. Sir, it's a sample data, no?
sample data.
Uh,
It is asking about correlation coefficient, right?
wait, 1 second, sir. Yes, sir, but when they are finding its standard deviation, they are using n
One
instead
second,
of
one
n
second, one
minus.
second. Let me clarify. Let me clarify. Okay, correlation coefficient is what? Covariance divided by standard deviations multiplication, right?
Yes, sir.
Now,
Sir, its n term will be cancelled.
one second. N term will be cancelled.
Yes.
What you will get at the end? Basically, okay, be careful if you are using the population covariance, then use the population standard deviation in the denominator also, right? You can't use population in the population covariance formula in the numerator and sample in the denominator. No, if you are using the population covariance in the numerator, use the population standard deviation in the denominator as well. Okay, let me clarify why. If you use, it will be summation of 1 upon n summation of xi minus x bar yi minus y bar, right? Whatever standard deviation, it will be 1 upon n summation of xi minus x bar square root of these things, correct?
Yes, sir.
Okay. So what you will get, 1 by n will get cancelled out, right?
Yes. Yes.
If you are using n minus 1, then use n minus 1 for both. Okay. So at the end, R you are going to get summation of xi minus x bar into yi minus y bar divided by square root of summation xi minus x bar square root of summation yi minus y bar. So you have to use at the end you can use this formula. Okay.
Oh, yes, sir.
Okay.
Sir,
So I think
Sir,
yeah.
sir, the
we have
best fit line, is it just a line or a value, sir? Best goodness of fit.
Okay, goodness of it. Okay, don't I mean worry about that much. Okay, that you can simply get from in your Google sheet or Excel sheet. Okay, but we are not going to study that much depth about goodness of it. Basically, it's just basically if you plot the scatter plot, right, then R square basically tells us the variability explained by your explanatory, I mean independent variables in your data set. I mean how much variability is there which is explained by in your data set. Basically, this R square is very useful when you are going to study the regression and all. Okay, so don't worry about that R square that much. Okay,
Sir, this R square is small R square also, sir. Both of them are same.
values are same, range will be same.
Okay, so values of small R square and capital R square will be the same.
Yeah, R square this basically this capital R square I mean it represents, I mean it explain the variability in your data set. Okay, uh, which explained by your independent variables, means your x variables actually. Okay, so
Sir,
suppose R square you are getting 57.7, that means 57% of the variability is there in your data set, which is due to independent variables, which is explained by your independent variables. That is the meaning. So we are not going
sir,
to study that much depth. Yes.
Okay, sir, here variability is the variation of the
Variation, yeah. Okay, how much variation is in your data set? If variation is your data set, how we can explain that data set? Basically, if you study the linear regression, right? Basically, y is equal to beta naught plus beta 1 plus x. This is simple linear regression equation. That's not in our course. I'm just going to give you idea. So for this, suppose you feed the line. You feed the line. That I mean, you will get estimate of the this beta naught and beta 1. Then error term will not be there. Suppose for this, you are going to get R square, let's say 0.70. That means 70% of the variability is explained by your explanatory variable, which is x, and remaining 30% is due to error. So that's the something else. So basically, R square just represents the variability in your data set. Okay, don't worry about that much. Okay, we are not going to
Sir,
do
but
that
how are
much.
they
Yeah,
conceptually related, sir? One is standard deviation and that thing, and the R square is the same thing is variability here.
it represents basically. See, if you see x and y, right? Okay, y is your dependent variable, response variable. X is independent variable. Yes or no?
Yes, sir.
So R square saying suppose 0.7, right? You plot this curve and you find the best fit line, right? Something like that. That is 57% of the variability. Who is this? 57% of the variability is explained by your independent random variable, your explanatory variable. Okay.
Sir,
Yes.
I want to know today at 10 p.m. we have a office hour by TA.
Yes. Yes. Yeah.
Can you complete the remaining revision?
Revision will do on Friday because we have not informed to rest of the people because most of the people have left the session. Okay, we'll see there are only two concepts remaining: correlation and point by serial. First, we will
Yes.
cover that one and we'll discuss the questions of mock. Don't worry, we'll cover
Sir,
on
I
that.
have posted a question in the chat. Could you please check that question? It's just about the descriptive and inferential.
This one, a researcher wants to. This one, a researcher. Hello.
Yes, sir. It's question she has posted.
Okay, a researcher wants to investigate the relationship between studying hours and exam scores. He collects the data on studying hours and exam scores from a sample of 100 students and perform a correlation. And which branch of study does this belong to? Okay, what are the options? Inferential or descriptive, right? Hello.
Yes, sir. You are audible.
Yeah. So basically, answer I think is this descriptive, right?
Yeah, it's the answer. It's descriptive only.
Yeah.
But I have a doubt in this. Say he's taking a sample and concluding
Okay.
the thing.
Let me clarify those that. Okay. So what that researcher has done, he took a sample of 100 students. Okay, let me clarify first. I think you can. Had you attended the revision session of week 1 and week 2?
No, no.
No, right? That's it. Okay, so what I will prefer you, I will explain right now. Don't worry. What I will prefer, just go and rewatch. We have discussed descriptive and inferential very, by
Yeah,
taking
sure,
two
sir.
different. Okay, let me clarify here. Okay, so what is meaning of descriptive and inferential essay? Okay, let me take another example. Okay, suppose you have given the data set of, let's say, what were the
Actually, I'm clear about the inferential and descriptive. In this question,
basically what that analyst have done, he took the sample of 100 students, right? Okay.
Yes.
He took the sample of 100 students. Now what he has done on this 100 students, he had done some correlation analysis, right?
Yeah.
Okay. What he has done? Now he stopped here, right?
Yes.
He had a data set of 100 students and he has done some correlation analysis, like say correlation between marks and studying hour is, that's a 0.86, something like that. What basically he has done, he has described his data set, whatever
Yeah.
data set he has, he stopped here, right? This is called something
Okay.
descriptive. Whatever data sets you have, you are just described. Suppose he can simply say average marks of this data set is something else, right? Maximum marks is something else. minimum marks is some. Okay. Suppose you are analyst, okay, and I gave you a data set, and I asked you to describe this data set. Okay, this sample of 100 student data, right? And you told
Okay.
me, sir, average is this, maximum is this, minimum is correlation between their hours of
Yeah, that will be
yesterday.
descriptive.
That
For
will be
me,
descriptive.
that's fine. The
Then it
first
will
line is only confuse me.
Okay.
He's trying to study the he
Basically,
wants to
okay,
invest.
let me clarify. When it will be inferential, once you will say, that suppose there are some 10,000 students, right? After this, suppose you have done this analysis, right, on your data set. Once you are saying, after analysis this, you are saying the correlation between yesterday hours and exam performance is 0.86 for this 10,000 students, then it will be inferential. Basically, you have done something on this. If based on that summarization, you are making conclusion about your population, right? Then it will be inferential. If I will stop here, right, then it's a descriptive. Means
So the
descriptive,
question,
whatever data set I have, I stopped there. I just described, I just summarized, stop. Correct?
So if we concludes, then it becomes inferential, right?
Inferential, right?
But if he has an intention of conclusion, for example, the question could be based on the correlation, he sees that there may be a possibility of selecting top 5 average students. Okay, this is an intention. It's an intention. It's not a conclusion.
Okay. Yes.
Is it still an inferential?
No, inferential means once you will make the inference, you are making the conclusion, then you can say, right?
Okay, so here he is giving an expectation, or he is giving.
He's just saying for his analysis, for his study, he took a sample. Okay.
Okay.
And he took a sample and he has done the correlation analysis on his sample. That's all. I stopped.
Okay, so since it's not explicitly given in the question, we can conclude it's descriptive.
Correct. Basically, let me take another example. Suppose you have given the some data set of, let's say, 10,000 bikes. Okay. Okay. So, okay, can you compute the, okay, suppose, see, now today's tech included, it is very easy to compute with the 10,000, right? For example, I'm saying, so what 10,000 bike, can you compute the average speed? Okay. You can tell me the maximum speed, minimum speed, or you can simply plot a bar chart, something like that. You can do, right? Okay. Yes, no?
Yes,
then
yes.
This will be something what? Descriptive statistics. Right? Right?
Yeah.
Now, okay, suppose I'm saying you don't want to do that based on 10,000. Suppose I gave you 10,000 data set of 10,000 bikes, and you took a sample of 200 bikes, for example. Okay. Okay. You took a sample of 200 bikes and you computed the average speed, okay, of these bikes. You computed the maximum speed, minimum speed, something like that, and you stopped there. And you simply told me this is the average speed, this is maximum speed, this is minimum speed, right? Then this will be descriptive. Yes?
Yes, sir, it's descriptive.
Yeah.
Clear? Now, so whatever data set you have given, you can simply, if you are summarizing the main points of that data set, you are describing that will come as descriptive statistic. That's why we call descriptive statistic can be performed on sample data set as well as population data set. If I'm going to consider this 10,000 bikes as a population, right? This is clear?
Yeah.
Now,
sir, can I read one example which is bit different?
Bit different.
I mean, whatever definition we understood about inferential and statistics, right?
Okay.
The answer seems to be a bit different. I'll just try to read out. Maybe we can quickly discuss. A construction company wants to start a house construction business in a city. Since there are a large number of houses, the company collects a sample of houses from the city and uses the properties of the sample to study the prices in the city. Okay.
I think this was in activity, right? We had to change.
This was an activity. Okay.
Got it.
I think
that statement we had to change actually. I got your point. Okay.
It's the same, right? Last time we discussed, correct? Yeah.
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 So basically that statement we have to change. We did not change so far. We have to change it.
Clear. It's clear then. It's clear.
Okay.
Sir,
Okay. So
but
basically,
it's inferential from this definition, right? Or this
so okay,
statement.
okay. Let me first of all let me clarify this one. Okay. So this descriptive part is clear. I can perform whatever data set I have given. I can summarize. I can describe that data set, right? Yes. No.
Yes. Yes.
So
Yes, sir.
right now, suppose this 10,000 bikes. I gave you data set of this 10,000 bikes, and you are considered as a population data set. Suppose this is the total bikes in a city, in a something locality, in society, something like that. Okay, you can consider as a population data. And you took a sample of 200 bikes, and you computed this average speed, maximum speed, and now you are telling the average speed of the bikes in that city is, let's say, 40 kilometer per hour. Okay, then it's inferential. What you are doing, you are making the inference, you are doing a infer, you are making a conclusion based on this sample data set for the population data set, right?
Yes.
Yes.
Okay. Okay, that's something called the inference. Okay. So mathematics session is for which week they are revising? 1, 2, or 3, 4?
Sorry, sir. What?
In mathematics
3 and 4.
session 3 and
No,
4,
no.
right?
I think no. Sorry, they have not given anything as such.
Okay, they are just revising the things.
Revision session 1. They are saying.
Okay. That means they will revise today and day after.
And one question I had.
Yeah,
What is the use of this interquartile range, sir?
What is that?
Use of interquartile range.
Okay, basically, okay. So as a formula, it will basically, okay, see, IQR is nothing but just a measure of dispersion also. Okay, one kind of measure of dispersion. Okay, so which is okay. What basically a formula of IQR is difference between third quartile and
right
first quartile.
Basically, see, IQR gives the difference between Q3 minus Q1.
Yes.
Okay, so it's a basically it's also measure of dispersion, right? And it's a useful for whenever you have let's say data.
No, but why Q3 and Q1?
Sorry.
Is there any other some different range from Q4 to Q2?
No. It's a Q3 minus Q1. Basically, see what quartiles defined is something like that. It divides the data in 4 equal parts.
Understood. That is clear. But
that is clear,
only
right?
why Q3 and Q2?
Q3 and
Q3
Q1.
and Q1. Sorry, why Q3 and Q1?
Okay, so that's the something I need to check, but I can't say something clearly for that. Okay. So basically, it helps you. So suppose whenever you have skewed kind of distribution, right? Not a symmetric. Symmetric means it's symmetrical about your mean, something like that, right? When it's skewed data set, something like that, or you have data set with outliers, right? So in those scenario, your count this IQR is helpful. Basically, if you see the box plot, Q3 minus Q1, right? So that box gives you the difference. I mean, upper boundary of box that box is represents the Q3, and lower bound represents the Q1, right? Lower bound of that box.
Sir, your screen is not visible.
Pictorially, it will help to visualize.
It's a pictorial helpful, basically.
Okay.
Sir, I have dropped a question in the chat, sir, regarding activity question 4.6. I have got 2648.25 as the answer, but it says 39. I checked and I think I didn't make any mistakes, but can you revisit the question?
Okay, 2, 4, 7, 11, 30,
Yeah,
49, 6. Okay,
Yes.
covariance you have to find out. Sample covariance, right?
Yeah.
Have you divided by 4 or 3?
4 only, sir.
Why?
N minus 1 only, no, sir. So
it's only 3, right? N is 4.
Yeah. Okay.
Got it? Be clear with that sample covariance population, right?
Yeah. And in the exam, the standard deviation, covariance, and all, we have to calculate manually, right, sir? They will not give any Excel help and all.
No Excel help. You have to calculate manually. But don't worry, calculation will not be that
the
much.
Squares, the squares and all are there, no?
Yeah. It will be. See. Calculation will not be that much difficult.
It will not be heavy calculation. It will be whole number, I guess.
Yeah, it will be some easy. If there is something heavy calculation or something, so I think there will be less number of questions. It will not be like in every question you are going to get some 25.3879 square of this something. No, it will not.
Right.
Don't
For
worry
example,
about that.
in the current one, 87.13 and all, no. So this
Yeah.
is a difficult one only.
Yeah. Basically, see, in practice, GA, you might get some difficult calculation and all, but in quizzes, basically, we are going to check your concept, whether you are able to identify and apply or not. That's okay. Don't worry about will give some big calculation and you are busy with in only calculation part. No, that's not the case. Okay.
We can also use calculator in the exam.
Calculator, only TCS scientific calculator will be there on in your system. Okay. No physical.
Yes, we can use that.
Yeah, you can use that one. No problem.
Yes. Yes.
Okay, then I think
And there will be no keyboard support, right, sir? Only it's mouse. You have to operate only through mouse, right?
yes, I think scientific calculator we can use with the mouse. Keyboard is, I think, it's not accessible for that that calculator actually.
Yes, sir. It's not.
Yeah,
even
you
on
have
the
to use your you have to do with your mouse. Okay, then let's meet in the upcoming session, right? We'll discuss the concept, remaining concept correlation and point by serial, and after that we'll discuss the mock questions.
Bye.
Okay. Okay,
Is there
thanks.
any
Hope you got.
Sir, the answer,
Yeah.
sir, the answer is still like 3,000 something, sir. Divided with 3 also. I guess, I mean, I didn't make a
3,000?
mistake. I'll let you know. Give me a quick second, sir. Yeah.
Okay. Good.
3531. It's not coming 39. I don't know why.
Okay. One second. Let me. Okay. Just give me a minute. Okay. Can you tell me the observations?
Division of x.
One second. Let me share my screen. Is my screen visible? Can you say,
Yes,
tell me the observation 2?
2, 4, 7, 11.
2, 4, 7, 11. Then
30, 49 in y.
30,
Yeah,
49 and
60, 55.
60,
55.
55.
That's it.
That's it, right? So you have to find out the covariance, right?
Yeah.
One second. Covariance between this set and this set. 29.25 is coming out, right? So you're talking
Yes,
about
sir. I mean, covariance of sample.
39 is there.
But when I calculate, it comes around 3 something. 3,
Okay, one second. Okay, first of all, we have to compute the x bar, right?
Yeah.
That means average of this, correct? Then average of this y bar, right?
Yeah.
So far, so good. Now, right? What you have to do? Xi minus x bar, right?
Yes.
Right? That means xi minus x bar. Okay. So we have to fix there. Otherwise, okay. So it will be like this. And next, you have to do yi minus y bar.
Y bar. Yeah.
Okay. So I think this is something, right? Now, next, you have to multiply these two, xi minus x bar into y minus y bar, right?
Yes.
Correct. Then you have to add, right?
Yes. Then I divide by 3. Yeah.
Right. This is 170. 117 divided by 3, 39.
Yeah. I guess I
think
made a mistake.
that might be possible.
Yeah.
You have made some calculation. Recheck it, okay? Sorry, sir. Okay then. Thanks. We'll meet in the upcoming session. Okay. Thanks. Bye. Hope you got the concepts of week 3. Okay.
Yes,
bye
sir.
everyone. Bye.
Yeah,
Bye.
bye.